Hey, so we're going to talk about a platform we have built. Oh, cool. Does this change slides? Nice. We have been building this for a long time, since like 2019-ish. We've been in this space for a lot longer, though, since about 2009. Most of the time when I talk about this slide has that, and we'll go through that. But that would have been like 85% redacted text, because it wouldn't have been cleared and like wouldn't have been a good slide. So we're going to talk a bit about what it does, why you could want to deploy it, and our goals. So one of the big problems with a lot of these sort of bring your own tool, and we will scale it up, store your stuff, is that you've got to spend a ton of time adapting that tool to get it pulled in. We have had people on prior platforms build a tool, get the job done, then come to us saying, hey, could we build this into some bigger system that you've got? And basically say, never mind, I'm not going to go down that path. That will take a ton of time, and we don't get anything for that because we got our job done. So we were trying to solve that. We don't want you to spend time changing your tool to fit into some big system, running into problems where, oh, that tool is now stuck in some big system because you had to adapt it just to fit into that, and that comes at the cost of portability. So just to go over some of the top level features of Thorium, you don't have to spend a ton of time to get tools pulled in. Most of the time, you don't even have to write any code. The other time, you can do it with a single one-liner bash script. It can scale to a ton of data. We've got a little bit over 6 billion rows. I can't go too far into what that data is, but we've got a ton of it, and you could scale to that also. We support both static tools and dynamic. So if you've got tools where you don't trust them and you want them to run somewhere where they can't talk out, you can do that. If you've got tools that do have to talk out. Like if you wanted to run Prowler, you could. We support multiple K8 clusters. So like if you wanted to have one for on-prem, one in AWS, you can. We've got both a GUI and a command line tool. You can talk to it, talk to the entire system using a RESTful API. If you say, cool, but your UI is awful, awesome. Build your own. Please, please give that back though, right? Like, you post something to GitHub so that we all get brand new cool stuff. This was built to be multi-tenant. Sandia's big. We support a lot of different government agencies. Most of the time, one team shouldn't see other teams' stuff. They shouldn't even be able to tell. Two totally independent teams are both trying to look at one particular sample. We do full text search both of tags and of tool results, and you can do multi-tag. So like if you wanted to say, tell me all of the data that is PE files from this particular malware family that does process hollowing, you could. We've got a bunch of tools pulled in. We're also going to talk about a standard that we built to attempt to solve this problem of how do we give tools to others. So one of the big things that you can do is you can combine a bunch of smaller tools into a complex pipeline. So the goal here is if you get something packed, you can basically pass that to the system. Thorium will spawn some number of baseline tools just to understand what did we get. It could then go, oh, this is a packed file. Someone gave us a compressed archive, something, right? I'm going to unpack that. I'm going to run some particular tool. Then, based on the tags from that tool or from the pipeline that you built, it will then spawn some other tools, and you can basically continue to do that until you get to some end. So now we're just going to jump into a demo. Most of the time, I would be doing this on a real system. Sandia told me no, so we're not doing that. We're going to pretend someone got a really awesome email about buying a bridge in Nebraska. They really want to buy this. Sounds like a good business idea, but they were smart and went to their security team and told them, "Hey, is this good?" We come back with, "Nope, probably not," but they really want to buy this. We've got to come back with like, "No, here's why." What we're going to start with is we're going to go to the GUI, drop that email and put it into some particular group. We'll put some info in. We will also give it a fun tag. We'll put something in so that we can come back to this, and then we will basically click upload, and we've got it in the system. It puts some info in, but there's no tool results because this is a brand new instance. We didn't install them, which isn't good. Then you don't get stuff to go back to them saying, "Please don't buy a bridge." So, and I just talked about that. We're going to first cover why our approach to tools is special, what we do. So the entire backend is all built in Rust. If you couldn't tell by the fact that all of my slides have a ton of crabs, I am still trying to find where Sandia will come back to me saying, "Stop putting so many pictures of crabs in." But we basically take your Docker image, we inspect it. We can then tell, "Oh, you were going to call X." We then inject in a statically compiled agent that does not depend on the system at all. We had to solve some issues where someone was building Docker images and wasn't building in a linker. So I can confidently tell you, you can run this agent anywhere. What this will do is it will pull the data that you're trying to scan, whether that be a file, a GitHub repo, anything. It will pull the down prior tool results if your tool depends on it. It will run what you were going to call. It will pull standard out standard error, send that back to the backend so that if your tool goes bad, we don't just come back with, I don't know, problems, figure it out. We can come back with problems. Here's the standard out. go and solve that. So, but basically, Scalar gets your Docker image, inspects it, injects agent. At runtime, we don't build a Docker image on top, and then agent gets told to go. So that's still good, but trying to give people tools still kind of a giant pain. Trying to get a brand new instance up, still kind of a giant pain if you've got 50 tools. We have built to solve that problem a tool import capability where you can basically put a JSON file in your GitHub that will tell the system, hey, this is my Docker image. It needs 2 cores, 8 gigs, 1 AMD GPU, and you can also say like, and it's going to depend on this other tool, string them together, take the tool results from A, pass it to B. There's a bunch of stuff that you can put in that. That's still a beta. If you build tools and you want to talk about what things should we put into this, please come and talk, or during the end of this talk, raise your hand and tell me what we should do. So we're just going to import all of the tools that we just open sourced integrations for last Friday. So we've got a bunch of them, and with that one thing, all of those tools are pulled in. Thorium's been told when to call them, how to take tool A, pass it to tool B, all of that, and we can now actually find out, should this person buy a bridge. So we just spawned some jobs. We're going to jump to one of them. You can get both like a status log and the actual standard out, standard error, and we're going to wait for the tool to get spawned. It will take like 10 seconds. So while this is going on, the autoscaler is basically inspecting image, telling some K8 cluster about it, and then pulling it down. Okay, so that tool got spawned. This is just an email parser tool. All it's doing, pulling out attachments, body, to, from, headers, all of that. So now we have got a bunch of tags. You can click on any of them and it will jump to, this is all of the data with that tag. And we're just going to scroll through some of the tool results that we got. So this is the email body, somewhat ugly. That is one thing that we are going to be improving, and it dumps a ton of stuff. But there isn't really anything in this that we can go, oh, please don't don't buy this wonderful bridge. It does contain one attachment. That was the child that we scrolled by. We'll just continue on. So if we were going to say, okay, let's go to that child. We've got a relationship graph that you can plot this, drop that, or this particular file is tied to some other file due to tag or something. So that file just drops a binary file. Turns out it's a PDF supposedly containing info on this wonderful bridge. Still, though, we can't go back with, hey, bad. So now our goal is, okay, can we get a preview of that probably bad document? So to pull a tool into Thorium, all you need is a Docker file and the tool if you are going to run it within K8. All of this here probably too small. There is no special stuff there. We don't have anything tied to Thorium in the actual tool. You could pull this tool from the Docker container, run it on your box. It would do the exact same stuff. In the actual Docker file, we do put a -o saying, hey, put stuff there, but you could do that in the UI if you didn't want to change some Docker file. If this was a tool that you pulled from GitHub. So if we do want to pull in this tool, which we do, all you have to do, go push that button, call your tool something, put something in there saying this tool does X, and then you're just going to basically tell the system Docker image is here. And then we've got a bunch of possible options. Most of the time people will just say this thing has to take 2 gigs, blah blah blah, but like you can bind in volumes. This particular tool, because we are going to be rendering a PDF, we don't trust it. So we're going to run it on the Kaboom K8 cluster. Not a term that you need to care about, but we put a policy in there saying, hey, you can talk back to the Thorium API here. Now we're just going to go in, call it. So if you can tell, we have got 2 tools in there. A pipeline can contain as many tools as you pick. You can go K8 tool, bare metal tool back to K8. Like you can run 10 tools at once, then all of those go into some tool after. Both of those tools got done. We're then going to go back to the sample and PDF preview blank, which if you read all of the email at the start, they told us, hey, if you get a blank page, try to run this on your AD server, because it contains giant high def pictures. We can also look at other tools. It appears this particular document drops a child object and then attempts to run it just based off of that there. So we can then look at one other tool, binwalk, which will go through that document and then dump all of the children. We can go back to our graph and say, okay, one of those children looks bad. It's got a suspicious Yara hit. All that is basically this particular document contains a font file. That font file is bad. If you did run it, it would run code on your box. So like the core goal here that I'm trying to tell you is, don't spend a ton of time pulling in tools. Systems that attempt to have you change your tool to fit into them are bad. The system should be doing the opposite. Like, if you spend more than one hour trying to pull in your stuff, most of the time analysts just aren't going to. They've got a ton of stuff to get done. Their whole job's very time sensitive. We want to help them get the job done, not give them stuff to get done on top of that. So just to go back, email, PDF, bad font file. All of that was done in the system. If you put that email file into it after having all of these tools in there, no one has to ever click anything. Thorium could go, oh, I've got an email. I'm going to dump the attachments. Oh, I've got a PDF. I'm going to pull stuff from that, and then your analyst can just go from here's email to here's the bad child that it dropped, and you can apply this to a bunch of stuff. We've done it for a lot of different asks. If you want to build a giant data set, you could. If you wanted to say, I don't know, scrape GitHub and build a 30T data set of stuff built from GitHub, you could build that into this system. If you wanted to put that data into ML models, you could. We do it a ton, both for trying to build brand new tools, in that we need to be positive our tool does the job every time. So we will pull the tool and run it on a ton of samples, and then come back with did all of the stuff that we expected it to hit, and did anything blow up? Did we get a bunch of stuff that we didn't intend? And is that good, bad, all of that? What should you not use this for? So we don't support interactive tools, right? Like, if this is something where your tool will do something and then someone has to pick path A, path B. Like, if you're doing symbolic execution, that could be done in there, but that's going to be tough. Most of the time, people have to pick which path should we go down. We don't support files bigger than 50 gig. We could support files up to 5 terabytes. No one's come to me saying, please build that. I want to ingest disk images. But if someone did and I got told I could, we could. We don't support Windows tools a ton. There is a path where you can do them using our bare metal framework, which is all built into this, but it's definitely not as easy. So that could be something that we go down, but it's not there yet. If you do want to test this, you can go to our GitHub. We have got install guides. There are install scripts, both for small deployments, like just on a analyst laptop, and then there's also one for a big one, like if you wanted to run this across 10 boxes and 5,000 cores, you could, but you don't have to scale big. So the paths that we are going down, we are going to be stabilizing toolbox, where you can do a Thor import. The goal there is other tool devs can also have that, and we can build like a sort of tool app store. None of them would be tied to Thorium, there is no vendor lock-in. Anyone could put that JSON file into their GitHub. Our docs are going to get a lot better. This all began as a solely internal tool, so like the docs weren't super good. To install, it's going to get better. Also, it's gotten a lot better with the update last Friday, but it's going to continue to get better. That particular graph I pulled up, we've got a whole brand new build of that. We support a ton of stuff. So like if you wanted to dump firmware and you wanted to be able to say this particular firmware sample came from switch blah 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 building blah blah blah, you could. If you wanted to tie samples to vulnerabilities, actors, all of that stuff, you can. That is supposed to be structured. So one other thing that we're going to be doing better is we are very good at building you a giant pile of JSON, and that's good when you've got the time and the understanding to go through that, but it's not good for all. We are going to be building stuff so that you can put info into tools to say, hey, this particular part of my result is important. Please pull that out so that analysts can get a easy view of it. MCP, that's going to be coming. That way you can go to your chatbot and say, hey, I've got this particular sample. What does it do? Can you spawn tools? What do I spawn? All of that stuff. And the last goal is we build a lot of tools. We talk to a lot of government people, but we don't talk to a lot of the open source or the commercial space, and we would enjoy talking to all of you so that we can more easily give our tools out, and we can also get stuff from others. And that's it.